Assalamualaikum. Good day. Today I'm preparing a video for you for the topic of exception handling. Okay. The objective of exception handling is to improve the reliability of your code by incorporating error exception. Before this, we used to do coding, and when there are errors, it is being shown on at the output section, right? So, along this all this while, you are actually not catching the error. You simply let the error or exception being released without doing anything on it. So, you will realize that when there are errors, the program will be stopped, right? So, when you are actually doing exception handling, whenever there are any exceptions that is triggered, the program will still be running, but you'll be seeing some error messages, which is meaningful, and the error might be handled either by you or by the program. Alright, so in this course, in this content, you'll be learning on how to write methods that by using try and catch, and at the same time, there is another way of doing it other than try and catch, which is by propagating the exception. So that will be covered in the other video. Alright, and then we'll also be looking at two types of exception. One is check and uncheck. This content is also will be covered in the other video. Okay, what is a good program? Okay, a good program is not just giving correct answer. Okay, it must also handle situation where errors occurs, maybe in terms of invalid input. Okay, or invalid file, or maybe the file that you want to access is not there. Okay, should not crash easily. Okay, you don't want your program to easily terminated when there are errors. You should handle the exception before it crashes. So what is exception? Exception represents an error condition that can occur during the program execution. So it happens when you run it. It's more like a runtime kind of error. Okay. The normal exception that you might experience is invalid data. Alright, you want the user to put numbers, but the user actually spell out the numbers. Okay, division by 0, trying to open an input file that is not there, maybe it's not in that folder, or array out of bound. Okay, you have experienced this before. So when an exception occurs, the normal flow of the program is interrupted. Okay, so along the way there are several codes that the compiler is compiling, and then when the error occurs, when the exception occurs, it will terminate. Okay, which is not recommended. Maybe before this, when you first time learning programming, so it's okay to have your program terminated because you keep on fixing the error, right? So all those kind of things. But as you go along, you want to create a more stable program that does not simply terminate it. Okay, so you should be thinking when you do the coding, where might be the error occurs, especially when there are some input taken from the user. So you should be extra careful with that. So when Java Virtual Machine find an exception in the code, we say JVM throws an exception object. So that is what happened before this. Whenever there are any exception or errors, it will be terminated, and you can see all the message in the output section, right? So that is what happening all this while. And the normal sequence of flow is terminated if the exception object is thrown and not caught. Okay, so whenever the error or exception happen, so it will be thrown. So that is what happened all this while. When there are an exception, it will be thrown, it will be shown to you. And because all this while we never handle whenever there are errors, right? I know some of you have done it, but most of you haven't. So that is what we are going to learn. Okay, this is a very short example to show where exception is thrown, shown to you, but it's not caught. Okay, so I think that is normal scene for us, right? Whenever, let's say, you have a scanner, you use a scanner and then you're expecting people to enter an integer, but what happened? The user actually type the word 3, so error will be, exception will be thrown. So that is how you normally see it, right? So this is actually what JVM is showing to you. So it's showing here that the exception is input mismatch exception. Okay, so error stack trace message. So this is actually stack trace error. So it's tracing where does the error happen. Okay, so when that kind of error happen, have you look at just now? So the main stop, okay, from executing, because once an exception has been thrown, it must be caught by an exception handler and dealt with immediately. Okay, since we do not have any exception handling of our own, because we don't write it there, so this exception is caught by Java runtime system. Okay, the default handler displays a string describing the exception. Okay, print a stack trace from the point at which the exception occurs and terminates the program. So the one that you have seen just now, there is a line of um, exception. Okay, starting from where it happens until it terminates. So that is a normal view for you, right? And also for me. So whenever you are executing your code and there are errors, you are used to that. Sometimes you simply ignore it, but it's good to actually look at it and trace it. Okay, where does it happen? Right, in this content that we are covering, so we are going to learn how to handle the exception. Okay, you will be writing extra code on top of what you are writing for your program to handle the error. The exception handling code can then be executed to catch and handle the exception object. So we say the thrown exception object is caught. Okay, what is this? Okay, let's have a look at more example. Um, right, there are actually many types of exception. I think the normal one that you might be experiencing is that when you use scanner object, maybe there is an input mismatch exception. Normally the type of input being entered is not the one that we want. Or sometimes when you do some calculation where there are division with zeros, you can see that class arithmetic exception is being shown to you. Okay, so this is basically what are there in Java to handle exception. So the superclass is actually from throwable, and the subclasses underneath it is error and exception. In this course, we do not handle errors because errors there are a variety. The one that we are targeting for is actually exception. Okay, exception is can be further down divided to several subclasses. IO exception, this is related to file. Maybe you're trying to access a URL that is not in the correct manner, or maybe you are trying to access a host which is not there, or you are trying to read a file and it's an off file kind of exception. And then there is also a exception related to class not found. Maybe when you are trying to access a file, clone not supported exception. This is when you are using the function of cloning. Maybe you are duplicating certain objects. And the one that you've been experiencing all this while is actually a runtime exception. Alright, so I think in programming 1 you learn about this. Yeah, so it happens when the program is running and it is terminated for certain reason. I think we have come across to this just now, arithmetic class exception. I think you experienced this in the previous class where using polymorphic reference. Okay, trying to access an object which is not in the correct type. Okay, and then illegal argument exception. Okay, number format exception. Illegal state, index out of bound. This is related to array, no such element, input mismatch exception. Okay, you put wrong type of input or null pointer exception. Okay, so there are actually many classes to handle exception. Okay. All right. So how do you actually handle exception? Okay. First one is do nothing. I think that is what we used to do all this while. When you start learning programming, you are basically trying to make your program runnable, but along the way there are errors, right? So you simply do nothing about it because you want to fix your code. I think that is what we used to do before. And in this class, in this semester, we are trying to teach you on how to do the second and the third approach, which is try to catch the error and then try to handle it. Okay, try to fix it and tell the user about it. Okay, when there are errors, sometimes you want to tell the user what was the error and let the user decide. Okay, and the third way on how to do it is to propagate, to throw it. Okay, let the method caller, we tell the method that call the piece of code where the error happened or exception happened. Okay, we tell the method caller about it and let the method decide what to do. Okay, when you are doing exception handling, there are several keywords that you should be familiar with. The first one is try. Okay, try block. Normally we will say it's a try block. Try block is the part where it contains the piece of code that you are running. Okay, and you are suspecting that that part of code might trigger the error or exception. So when that happens, you put it in the try. So basically, if you have a very long code, you don't put everything in the try block. You normally choose. Okay, whenever you think an error might happen there, maybe because there are some calculation that you need to monitor, or you are expecting user to key in something there. You think that maybe the user might choose a wrong option or wrong type. So that is the part where you put it in the try block. Okay, the second keyword that you normally use together with try is catch. Okay, catch block can catch an exception and handle in a logical manner. When you are doing catch, you can have more than one catch. You can have several. Okay, we have a look at it later. And then you have another keyword which is called true. Okay, true and truth. Okay, we'll be covering on this in the other video. Okay, but as for now, I'm just explaining to you what throw is. Okay, throw is a system generated exception automatically thrown by the Java runtime. So you are using the one provided by Java, like the one that you have seen just now from the class hierarchy. Throws is if a method is capable of causing an exception, then it does not handle. It must specify this behavior so that the caller of the method can guard themselves against the exceptions. So by now, when you are doing coding, you have many methods, right? And maybe when you are writing the code, you feel that in this kind of method, maybe they will error occur. Maybe because the calculation is being done there, or you accept certain inputs from the user, from the keyboard, or from the screen, right? So you think error might occur there, so you can use throws. Okay, and it must specify this behavior so that the caller of the method can guard themselves against exception. Okay, the throws clause is included in the method header. You put the keyword throws at the method header. Okay, have a look at it later. And there's another keyword that you can use to handle exception, which is finally. Okay, finally is actually a block of code where whatever happened, whether there is exception or not, this part of code will be executed. Okay, how does it look like? So this is the try block. So, and then it is a catch block. You can have more than one catch. So you can, if there are more than one, so you can arrange it as like, from top to bottom. Okay. If error does not occur, the catch block will be skipped. Okay. When there are no errors, whatever in the catch will not be executed. If error occurs, the try block stop its execution immediately and jump to the appropriate catch block. Okay, catch block is only executed when error occurs. Okay, this is a graphical way on explaining this. Okay, for example, you have try, so yeah, you are suspecting that maybe this piece of code will trigger some exception. So you put it in the try block, and then on top of that you have catch. This catch block will actually handle whenever error happen in the try block. So let's say you're executing it and the error actually exception actually happened at statement 3. So when statement 3 happened and an exception happened, so all this code after line 3 will not be executed, it will be skipped. So what will happen is Java will directly go to the catch block, try to either identify, it will print something either to show what is the error, or maybe there is a message that you want to show to the user when this error happened, and after that it will do whatever code after the catch block. Okay, let's say there is no error happen here. Okay, the user is doing as expected, so no error, so it will only execute the try block and it will skip the catch block and do whatever code after the catch block. Okay, so basically that will happen when you do try catch block. Okay, a very short example on this. Okay, let's say you have a scanner where you want to get input from the user and you are suspecting that maybe some error will happen here. Maybe somebody will enter other than integer. So you put this code in the try block. Okay, try, open and close. So it's a block. So, and you put catch and then input mismatch E. You can either be E, F or anything. Okay. And then in here, the catch block basically trying to print something, say invalid input. Please enter digits only. Okay, let's say when you run it, the user enter number 10, no error. So it will execute normally and then it will go out of the catch and execute after the catch block. So the number you entered is, for example, 10. Okay, so let's say if you run it, somebody enter rather than number, something else, maybe a string, so it will block, the execution will be stopped, it will go to the catch block. So this part will be implemented. After this is implemented, it will go here. Okay, so not a good example. All right. Okay, and this is an example where the exception type is arithmetic exception. It's related to this one is a class and there is a main method there, and then the try and catch is actually in the main method. A try and catch can be either in a any methods other than, it can either be in a main or other methods. Okay, for example, you put this, you're expecting, of course in this example you are doing division by 0, so you are expecting that the arithmetic exception will be triggered, will be true. Okay, so you do try catch, this is try and then catch, you put arithmetic exception E, and then in here basically you want to say whenever error happened, so you bring it out. So what happened here, the error actually happened in this line of code, so this part is not executed. So what happened when the error happened here, exception happened here, it straight away go to the catch and bring it out. Maybe what you have seen just now is only a normal exception to you, right? arithmetic exception, okay, mismatch, area out of bound. Okay, you're trying to access an index which is outside of the range. For example, this is the class main method, and then you put this in try catch. Okay, and then of course you declare it with size 10, but you try to access it outside of the bound, outside of the range. So what will be triggered is array in that out of bound exception. Okay, so when the error happened here, a 11.9, so it will terminate here. It goes straight to the catch block, and this will be printed. Okay. Maybe you'll be asking me, will I have to remember all of this exception? Okay, so I think the common one maybe you can remember, but other than that, will you be able to know what kind of exception it is? Okay, to handle this, there is a method that you can use, which is called get message and print stack trace. Okay, so this method will actually, when you use it, it will return the message string of throwable. Okay, it will tell you what is the error that is being catched. This one here is a method called print stack trace. Okay, this is actually a method that will print out to you the trace information of the standard error stream. Okay, so it is useful for programmer who would like to trace the error in the code. So it will print out where the line number where the exception occurs. Okay, so an example for this. So how do you actually use it? Okay, you have try block and then you have a catch block. From the previous example, normally you will you see it print something, right? But in here we are trying to print something, but you use let's say you say catch input mismatch exception E. So E will be used here. It can be E, B, C, and everything. So it's up to you. But if you see you put E here, it should be E here also. Okay, you are referring to the same object. E.get message. Or when you use print stack trace, you don't have to put system.out.println. It's actually printing it out for you. So let's say you want to use this method, you should put e.print stack trace. Okay, so that's how you use it. Or the example just now shows a very specific exception. Let's say you don't know what might be the exception being triggered. So to be on the safe side and easier for you, you just put exception E. If you still remember from the class hierarchy diagram that I've shown to you just now, exception here is actually the superclass. Okay, under you have throwable, and underneath throwable you have error exception, right? So this is referring to that. Okay, exception is a superclass of all check exception. We'll have a look at what check exception is in the other video. Alright, so let's say you don't know what is the error being triggered, so you can use the superclass here. So it will print out the message for you. Okay, for example, if you use like this, catch error, in this case you know what is the kind of exception being triggered, so you put arithmetic exception E. So you put system.out.println E get message. So you will see the message, what are the exception being triggered. So it says here get message is actually a method of the throwable class. Yeah, remember it's a superclass of the exception of Java. Okay, inherited by every exception class like arithmetic exception. Right, this get message method prints only the message part of the output printed by the object A. So it only prints the message. This style can be preferred when a programmer would not like to give his message to the actual user. Okay, so it's still very readable, right? This kind of error message. So if you don't want to use get message, another option is to use print stack trace. I've mentioned to you just now, if you use print stack trace, you don't have to put system.out.println line. So it's from a global class. The good thing about this using print stack trace is that you can show the line number where the exception occurs. For example, it is in at line number 7. That error happened at line number 7. So it's normally used by the programmer. Okay, one more important thing is that you don't have to put system.out.println. Okay, so it can still clean it up for you. Okay, I have mentioned to you just now, when you use try catch, you can have more than one catch. Okay, you can have multiple. When is this applicable to you? It happens when in your try block you predict that there are several, especially if it's a very long try block. Maybe you're expecting people do several kind of exception, maybe wrong division, maybe divide by 0, maybe along the way you are using some array inside there, and then false. So when that happens, you can have multiple kind of catch block. Okay, so for example, let's say it's a slightly more complicated try block where there are many action or operation happening there. So assuming that the error happened at line 3, whenever there is error there, so it will terminate at line 3, and then it will go and find the exception which is related to whatever exception happened at line 3, execute the correct catch block, and then skip all the other catch block, and then execute whatever happened after that. Or if there is no error at all in the try block, it will only execute the try block until it's finished and skip all the catch block and execute like that. Okay, so that is the visual representation of what happened if there are multiple catch block. Okay, another issue when you have more than one catch block is that you need to be specific. You need to be aware that the way to arrange the catch block, you need to arrange the more specific one on top, followed by the generic one. So if you see here, exception is the superclass, which is more general, whereas arithmetic is more specific. So the way to organize it, you need to put arithmetic first and then exception later. Okay, how about this? Number format exception and arithmetic exception. Will this be okay for you? Okay, so you have to go and check here. Okay, number exception is here, arithmetic is here. Okay, so a more specific one is number format. Okay, so you have to put it first, followed by arithmetic. And there's another keyword that you can use, which is finally. Okay, finally is actually a block where will be executed whether exception happen or not. Okay, so a visual representation of this is, right, let's say in this example, error happened here, exception happened here, so this part will be skipped, and then it will go and trick and catch block which is suitable for that kind of exception, and after that it will execute whatever in the finally block, and then it goes out and then continue execution. Okay, let's say there is no exception at all in the try block, so everything is executed, skip all the catch and do finally. Okay, so finally is the part of code where you want to implement regardless whether there are exception or not. Okay, so in this example, it's a simple class with a main, and then it's actually want to show division of 0 kind of exception. Okay, so for example, it's executing this. So num2 minus num3, 50 minus 50 is 0. So we are expecting that error will be triggered here. Right, so what will be happen is, so it will do this, and there are errors, right? So this part here won't be executed. It will skip straight away to the suitable catch. So in this case, it's arithmetic exception, and it will print division by 0 will be printed, and then finally will be executed. So catch block here and finally block here will be executed. Okay, there is another um, way of implementing exception, which is throw, and I'll be covering on this in the other video. Hopefully this explanation is helpful for you, and when we are learning about exception, we are actually trying to create a better program. So whenever there are errors or exception, it does not simply terminate. So you normally show very suitable or useful message to the user first, so that they know what is happening. Okay, and then the program continues, or it can be handled when there are errors. Maybe there is another method that can handle the exception. Okay, thank you.